Now we learn whether a function is analytical function or not. These are the two necessary conditions. If there is a complex number mu plus iv, this is a complex number. So we find two things. Number one, we differentiate mu with the respect of x and delta of y with respect of y. They must be equal to each other. Second condition, if we differentiate d mu with respect to y, it is the opposite with the minus sign dv over dx. That means mu generally represents the x and v generally represents the y function. Now I am going to explain with the question. Now consider this question. Prove that 1 upon z is analytic or not. Now as we know, z is equal to x plus yi. So this function becomes 1 over x plus yi. Now we rationalize this by multiplying x minus yi into x minus yi. So it becomes x minus yi over x square. This is y square and minus 1, that is plus y square. Okay. So this function becomes in the form of x over x square plus y square minus yi over x square plus y square. So now comparing with this, mu becomes x over x square plus y square and v becomes y over x square plus y square. Okay. Now in order to show that it is an analytic function, we have to find d mu over dx, dv over dy, d mu over dy and dv over dx. Now I am going to find out the value of each one by one. Now d mu over dx, which is equal to x square plus y square whole square. Now here x square plus y square into 1 minus x into, when we differentiate x square plus y square in terms of x, we get 2x. So here we get x square plus y square minus 2x square upon x square plus y square whole square. So ultimately we get y square minus x square upon x square plus y square whole square for the d mu by dx. Now we find dy by dv by dy, dv by dy. Now from here we get y upon x square plus y square, so we get x square plus y square whole square. Similarly over here x square plus y square, and this is minus y, so it becomes minus 1, then minus y, and when we differentiate this we get 2y. Okay, so it becomes minus x square minus y square plus 2y square over x square plus y square whole square. So we get y square minus x square upon x square plus y square whole square. Now we can easily observe that these two values are equal to each other. That means our first condition is correct. Okay. Now I am proceeding for the next condition. Now when we proceed for the next condition, we have here d mu over dy. That means we have to differentiate with respect to y. For this case, when we differentiate with respect to this, here we get what? We don't have x, so it becomes 0, and here it becomes 2y. So ultimately, what we get over here, in this case, we get minus 2xy over x square plus y square whole square. Similarly, we now find d mu over dx. So now also over here, when we differentiate, this is dx. So here we have y, so it becomes 0, and here it becomes 2x. Okay, because we have to differentiate with respect to x. Now it is all get what we get over here. This becomes 0 and it becomes 2xy over x square plus y square whole square. So these are opposite each other. That means they are equal to each other but with the minus sign. So it proves that 1 upon z is a analytical function. So now if we w is equal to 1 over z, then dw over dz is equals to 1 over z dz, that means z to the power minus 1 dz. So when we differentiate, we get z to the power minus 2, that is minus 1 over z square. Now we have this type of question also in case of analytic function, that there is a function of f mu plus iv where the value of mu is given as 3x square minus 3y square. Find the expression for the v considering k to be the constant. Now in this case, we use the formula in order to find the v. dv is equals to delta v over delta x dx plus delta v over delta y into dy. Okay, now we have the expression mu is equal to 3x square minus 3y square. So we can find d mu upon dx as 6x, differentiating this with respect to x, d mu over dy, differentiating this with respect to y, that is minus 6y. Now we have d mu by dx and d mu by dy, and we need dv by dx. So from the Cauchy-Riemann equation, we have d mu over dx is equal to dv over dy. Similarly, d mu over dy is equal to minus of dv over delta x. So in place of dv by dy here, delta v by dy, we can write dv by dx. In place of dv by dx, we can write this one. So we have delta v by delta x here. So we write, there is a minus sign. So we write it as minus delta mu over delta y into dx plus, in place of delta v by delta y, we can write delta mu over delta x into dy. Okay, now I am going to substitute d mu over dy. We have minus 6y, so we get 6y dx, and here we get 6x dy. Okay, and it is dv. So now integrating on both the sides, we get v is equal to, this is with respect to dx, we have to integrate, so it becomes 6xy and it becomes 6xy plus k. Okay, so xy, if we differentiate it, we get x dy plus y dx. So the integration of this is this one. So similarly, we can see over here 6y dx and 6x dy. So we can write it as 6xy plus k is v. So this is the proper expression. Now consider this question for the analytic function. It is given that mu is equal to xy and we have to find the value for the v. So when we differentiate d mu with respect to delta x, we get y, and d mu with respect to delta y, we get x. Now in order to find the value of v, we can write delta v over delta x into dx plus delta v over delta y into dy. We have this expression. But here we don't have the value of dv by dx. We have the values for d mu by dx. Now according to our theorem, we know d mu over dx is equal to dv over dy. Similarly, d mu over dy is equal to minus of dv over dx. Clear? So in place of dv over dv by dx, this one, we write d mu over dy. Listen carefully. dv by dx is there in d mu over dy. That means minus of d mu over dy, and it is dx, plus it is delta v by dy, which is d mu by dx. And here we write dy. So d mu over dy is x. So we write over here minus x dx, and here we write y dy. Now on integrating both the sides, we get its value. So when we integrate minus x, we get minus x square upon 2. Here we get y square upon 2 plus k. That means we can write 1 upon 2 y square minus x square plus k. So this is the expression for the v.